Okay, I'm going to teach you how to rationalize. I didn't do it. I didn't mean to do it. It was somebody else. They made me do it. That's how you rationalize. Ha ha ha. Not really. To rationalize means to get square roots out of the denominator. We've already done this a little bit, but I want to go into a little more depth. And we'll start out with something simple just to kind of lull you into a false sense of security, and then, boom, we'll hit you with something really scary, but probably not. Okay, so I have 6 over root 2. Multiply top and bottom by root 2. You get 6 root 2 over root 2 times root 2, by definition, is just 2. Some people would write this middle step. They'd write it as root 4 and then make it a 2. And then last thing you need to do is simplify, and you get 3 root 2. Okay? Let's do another example. I'll put it over here because I'm going to have lots of examples. So I'm going to put like a little box around this. That's kind of an ugly one, but that's okay. So my next example that I want to do for you, let's do square root of 2 over cube root of 3. Well, in this situation, to get rid of this cube root, I need to multiply by something that will cause this 3 to become a perfect cube. So what if I multiply by cube root of 9 on the top and the bottom? You have to do the same thing to the top and the bottom. Well, cube root of 3 times cube root of 9 is cube root of 27. These two things can't really do much with them because one's a square root and one's a cube root, so you just keep them separate. And then here, cube root of 27 is 3, and on the top I have square root of 2, cube root of 9, and that is my answer, and it looks lovely. Next problem I want to do for you is square root of x plus 1 over square root of x minus 1. Now, for this problem, I have to multiply by the conjugate. Just like imaginary numbers have conjugates, these radical expressions also have conjugates. So I multiply the top and bottom by square root of x plus 1 and square root of x plus 1. Okay? So I FOIL. I do first square root of x times square root of x is x, as long as x is positive. Outer, we get plus root x. Inner, we get minus root x. And last term, we get negative 1. On the top, square root of x times square root of x is x. Outer is root x. Inner is root x. And last is 1. I hope it's okay that I didn't draw those lines. They just get kind of messy, but it's just FOIL. I have a wonderful song about FOIL on YouTube and also on my website if you look for it. I also have a nice song about square roots too. You should check them out sometime. Okay, so I have x, and then root x plus root x is 2 root x. Can't do anything more with that. And then plus 1. And on the bottom, cancel, cancel. We just have x minus 1. And we're all happy. Now, I want to do a couple more for you. And I'm going to go on another page to do these. So I will write see last page for more examples. And then let's go to the next page that I create here, because I do want to do a few more examples before I go on. And the examples that I'm going to do for you are examples that you will see when you take pre-calculus B. So I thought, why not teach you how to do something now so that when you get to pre-calculus B, all the new things that you're learning, this isn't one more thing that you have to learn. This is something that technically you can do now. When you're taking pre-calculus B, at some point you will see something like this. Now this looks really scary, but it's really kind of cool once you learn how to do it. You can impress all your friends with how easily you can fix this. You're not allowed to have fractions inside square roots. And I don't want a fraction on the top of this thing either. I want to get rid of this fraction, and I want to get rid of the big fraction. To get rid of this big fraction, if this 2 could be made into a perfect square, it could be moved outside of the square root. Also, if this 2 were gone, it wouldn't be a fraction anymore either, and that would be kind of nice. So I need a number that can cancel this 2 and make this 2 become a perfect square, And if I multiply the top and bottom of my big fraction by that number, some wonderful things will happen. I think the number that I'm looking for is 2. So if I take 2 times the top and 2 times the bottom, that's all I did. I multiplied everything by 2. Well, distribute here. I end up with 2 times 1 is 2 minus 2 times this thing. What you're doing is you've got 2 root 2 and you're multiplying by 2. So let me put a circle around this so you can kind of see what's happening. I do my work off to the side here. Those cancel and I just get root 2. Okay, so now I have a root 2 over 4, right? 2 times 2. Well, split up the top and bottom and I get 2 minus root 2 over root 4, and that gives me square root of 2 minus root 2 over 2. Now this square root under the square root, not really a lot I can do with that. This is my final answer. You will see something identical to this when you get to pre-calculus. So now you kind of know how to do something that you technically shouldn't have to know how to do for a while yet, but might as well do it now since we're doing square roots. Let me do one more for you that kind of looks similar, maybe a little more challenging than that. Let's do this problem. Okay? Now this time I need a number that will cancel a 3, but also when I combine it with that 2 I get a perfect square. So I'm looking for, I need a perfect square. I need a perfect square with factors of 3 to cancel a 3. And I also need a friend for this 2, because if I had 2 times 2, I'd get 4. So 3 and 4, or 3 and 2 are my factors. So what perfect square has factors of 3 and 2? Well, 3 times 3 and 2 times 2, if I multiply all that stuff out, I end up with a 36. So my goal is to make this 2 become a 36. How can I make 2 become a 36? Well, what if I multiply 2 by 18? And multiply the top by 18? Okay, on the bottom I get 36. On the top, when I distribute, I get 18 times 1 is 18, and 18 times this thing, well, I guess it's going to give me 18 times root 2 over 3, and those will cancel, and I get 6 root 2 right here. Everything else on top stays the same. On the bottom I have 36 still. And then 36, when I square root that, I get a 6, so I don't have a big giant fraction under a square root anymore. And here I have 18 minus 6 root 2. A little more complicated because these two numbers were different, but I just needed a number that was a perfect square that could also, 2 could be changed into that number. So I needed 2 to be changed into a number that was both a perfect square and could cancel with 3. Kind of a challenge, but lots of fun. Okay, let's do one more problem. Well, let's wait. We'll come back to this, and eventually we're going to do one more type of problem that's like what you'll see in Pre-Calculus B, and I think you're going to enjoy it a lot.